Okay, welcome you all for this new session. It is on vibration isolation and transmibility. Okay, what is vibration isolation? Vibration isolation, it is to minimize the vibration in any machine, or if any machine structure, if it is receiving vibration from any machines, then we need to isolate it. Isolation means we need to minimize or nullify the effect of the vibration, but nullification, it is highly impossible. At least it can be reduced with the vibration isolators. There are two types of vibration isolators. One is the force isolator, another is the motion isolator. Okay, why the vibration occurs in case of machines? As we already know that there are rotating parts or the reciprocating parts. In case of rotating parts, if there is any CG deviation from the axis of rotation, there is obviously the vibration occurs, and that is the source of the vibration in machines. From this excitation, it goes into the foundation of the machines. So if there is any sensitive part in the machine or structure, then it leads to the failure of that part. So we need to avoid the vibration. Okay, to avoid or to minimize the vibrations, we are using the vibration oscillators. Okay, there are different materials are used for this vibration isolators, namely rubber, cork, felt, and many materials are there. For the type of load which is acting on the structure or the foundation or any machine part, okay, based upon the type of the load, different materials are used. For example, rubber is suitable for shear load, cork is suitable for compressive load. Okay, like this fashion. Okay, for different types of loads, different materials are used. So the vibration isolators, it is mainly used for to reduce the forces or the motion control. Okay, and transmibility. What is transmibility? How much the force is transmitting to the foundation. Okay, how much the force is applied and how much is the force transmitting to the foundation. Okay, this ratio is called as the transmibility. Transmibility, it is the ratio of the force transmitted to the foundation to the impressed force. Impressed force means what is the applied force. Okay, in case of machines, the impressed force, it is due to the deviation of the eccentric mass. Okay, it is denoted as epsilon. Epsilon, it is transmissibility ratio. What is transmissibility ratio? The ratio of force transmitted to the foundation to the impressed force. Okay, we already know that what are the forces involved in a machine. Okay, it is a machine, and there are many components can be assumed here. What is the source of excitation? That is because of the CG deviation with respect to axis rotation. Okay, that force, it is the harmonic force, that is F naught sin omega t. As it is continuous, it is the force vibration. And to control this, the elasticity of the machine, that is can be called as the spring stiffness. And there is also the machine which is located in the air medium or some other medium, it is can be considered as the damping system. Okay, so in overall, what are the forces involved in all these system? It is shown here. We already know the relationship between each force. Okay, where m omega square, as we discussed in the previous session, it is the inertia force due to the eccentric mass. Okay, for exactly opposite, to resist this force, there is spring force, and there is always 90 degrees, at the 90 degrees to the spring force, there is damping force, and this is the impressed force. Okay, sin omega t, F naught sin omega, sorry, F naught sin pi omega t minus pi. Okay, this is the impressed force, inertia force, spring force, and the damping force. Okay, these are the forces involved in a machine when it is subjected to forcing function and because of the eccentric mass. Okay, so let us see how to find the transmibility. Transmibility, as we discussed, it is the ratio of what is the force transmitted to the foundation to the what is the force applied. Okay, we already know that the force is transmitting. Okay, see here, this is the machine, it is attached to a foundation. So what is the force which is transmitting here? That is the spring force and the damping force. Spring force and the damping force, it is kx, it can be given as Ft is equal to square root of kx square plus c omega square, where kx is the spring force and c omega x is the damping force, where x is the displacement. Okay, so this x is equal to response of the system. It can be given by x is equal to, we already derived it, it is due to the response of the system when it is subjected to forcing function or a continuous function. X is equal to f naught by k, where f naught it is the zero frequency, divided by square root of 1 minus omega by omega n square whole square plus 2 zeta omega by omega n whole square. Okay, this is the response when this x is substituted here, and let us calculate this transmitting force. Okay, what are the transmitting force? It is summation of damping force and the spring force. Okay, if this x value it is substituted at the response of the mass spring system subjected to forcing function, it is derived. If this x value is put here, then we will get a transmitting force. Okay, this transmitting force, okay, see here, Ft, x value is substituted here, x value is f naught by k, and this term square root of k square plus c square omega square. Okay, this can also be bring into frequency ratio terms. Okay, simplifying this, we get the transmibility ratio, that is square root of the numerator value, it is 1 plus 2 zeta omega by omega n whole square, and denominator term it is the same, 1 minus omega by omega n square whole square plus 2 zeta omega by omega n whole square. So this is the transmibility ratio. So how much is the force transmitting to a foundation to the how much force is applied or the impressed force. Okay, so what is the phase here with respect to transmitting force? That is 2 zeta omega by omega n minus divided by 1 minus omega by omega n square. Okay, minus tan inverse of 2 zeta omega by omega. This is very important, many problems will be asked on it. Okay, this is the transmibility ratio equation, and this is alpha. This is the angle made by the transmitting force. Okay, it lacks the impressed force. Okay, these are two important angles. Okay, you can see in the figure. Okay, what is the phi and alpha here? Alpha. Okay, the angle made by the impressed force and transmitting force, this is phi minus alpha. Okay, this is phi minus alpha, can be given by this relation. And what is alpha here? Alpha, it is angle made by the transmitting force to the resisting forces. Okay, this is the equation for the alpha. Okay, so these are the important equations, and you can see here the relationship between the x-axis, it is omega by omega n ratio, frequency ratio, and y-axis it is transmibility ratio. Okay, for any value of damping, all the curves are coinciding at this point. At this point, omega by omega n ratio is square root of 2. Okay, what it is telling, when omega by omega n, when this frequency ratio is less than this square root of 2, okay, then Ft by f naught value it is more than 1. So the transmitting force, what is the transmitting force to the foundation? That is more than the applied force. Okay, if it is omega by omega, if it is more than square root of 2, then the transmitting force, that is lesser than the applied force. Okay, okay, similarly it is the phase angle and frequency ratio. Okay, the same thing it is explained here. If frequency ratio, if it is less than square root of 2, then transmitting force is more than the applied force. If frequency ratio is more, then transmitting force is lesser than the applied force. If it is equal, then if it is equal to square root of 2, then the applied force is equal to transmitting force. Okay, you can see this. Okay, thank you very much.